Okay, so let's go over number one. Number one first asks us to balance equation, so this is what you should have seen. And also for the net ionic. Remember that ionic takes anything that is aqueous apart. It disassociates it and keeps anything that's solid, liquid, or gas. In net ionic, I'm going to do the same as just ionic, but then I am going to just take away anything aqueous or any ions that had nothing to do with creating new solid, liquid, or gas, okay? So in this case, I have solid, so keep that one, liquid, so keep that one, gas, so keep that one. But I need to take apart my aqueous, so I took it apart, and then I realized I need to keep every one of them. None of them were spectator, so I need to keep all of it. And so this is what you should have seen. Remember, the charges only apply to the ions or the aqueous ones, and no charge for solid, liquid, or gas. Okay. The first problem asks you to solve for grams of sodium hydroxide. So grams of sodium hydroxide if I have 0.23 kilograms of sodium. So I'm gonna just go ahead and convert that in terms of grams. That's 230 grams of sodium. And I start with what I know, but I have grams here, so I want grams down here. And what kind of grams is that? It's from the periodic table. So that is 23.0. Then I say, all right, so 1 mole of sodium will always give me 23 grams, okay? So far, it's the same as what I showed you in class, but I'm gonna use the dimensional analysis way, so I'm just gonna keep going this way. So I have grams and grams, done. All right, so now I can go ahead and compare the ratio between sodium and sodium hydroxide, the one that's in question. So I'm gonna say, according to my problem, okay, I already know I have to put mole of sodium down here. But according to my problem, how many moles of sodium do I have? I have 2, okay? So I can cancel that out. So I'm gonna put a mole of NaOH here, so I can start converting it into NaOH. But if I have 2 moles of sodium, how many moles of NaOH do I have in my problem? And I have 2, okay? So then I can continue on and I say, all right, so I have mole of NaOH here, so I know I need mole of NaOH here. And I know that I want my answer in terms of grams of NaOH. So I can say, all right, so looking at the periodic table, for every 1 mole of NaOH, so go ahead and cancel out mole of NaOH, how many grams of NaOH is in 1 mole? And the answer is 40 grams, right? I've solved it by looking at the periodic table. Then I say, okay, so when I multiply straight across, then I am going to get 400 grams of NaOH. But 400 grams is same as 0.40 times 10 to the 2 NaOH. And actually this is better because then I can guarantee I have 2 sig figs here, okay? The next problem is similar. So I have to start with what I know. I only know the grams of sodium. That's all I know. And I can go ahead and solve for moles of sodium. Okay, so far that's the same, right? So cancel, cancel. But then I get down here and I say, all right, so in my problem I have 2 moles of sodium. But how many moles of hydrogen gas do I have? Because that's the one in question. Well, I only have 1, okay? So 1 mole. So my ratio right now as it stands is 1 to 2. So mole, mole, cancel. Then I say, okay, I only have 1 mole of hydrogen, but according to my periodic table, oh, no, it's not according to my periodic table. If I have 1 mole of hydrogen, because the question says, how many liters of it is produced? So I actually want it in terms of liters of hydrogen. So then I have to look at my conversion rate, and I say 1 mole is always going to give me 22.4. 1 mole cancel out. Only unit that's left over is liters of hydrogen gas. And so I know I'm on the right track. So I say, all right, this one divided by that one is 10. 10 times by half is 5. 5 times 22.4 would give me 110 liters of hydrogen gas. Okay. The last problem. How many grams of hydrogen would be produced? So let's actually keep all of it the same. Okay, so let's keep all of it the same up to this point. And then I'm going to say, okay, so if I have all of that, instead of saying this, let's just say that for 1 mole of hydrogen gas, I have 2 grams of hydrogen, because that's 1 plus 1, because there's 2 of them. Then my answer is going to be 230 divided by 23 is 10, times by half is 5. 5 times 2 is 10. So I have 10 grams, let's see, 1, 2, so 10 grams of hydrogen gas, but let's change that so it's 2 sig figs, so times 10 to the 1. So 1.0 times 10 to the first power grams of hydrogen gas, or 10 grams, and that's your answer.